Hello, my name is Johnny Cook. I'm a Senior Specialist Solutions Architect here at AWS. And today we're going to do a walkthrough and demo of fine-tuning Anthropic's Claude 3 Haiku model. Before we do our demo, I want to walk you through a little bit more about what it is when we're talking about fine-tuning Claude 3 Haiku. When you want to fine-tune a model, especially when you're fine-tuning Claude models, your intention is to increase accuracy and quality to further tailor that generative AI experience for your business. Amazon Bedrock is the only fully managed service that provides customers with the ability to fine-tune Claude models. Claude 3 Haiku is part of the Anthropic Claude 3 family of models and is one of the most affordable and fastest options on the market for its intelligence category. Customize Claude 3 Haiku with your own data and build applications that are specific for your domain, organization, and use case. You can adapt Haiku's knowledge to create unique user experiences that reflect your company's proprietary information, brand, voice, products, and more. And we'll see that in our demo in a few moments. Amazon Bedrock trains a private copy of your model while keeping your private training data secure. When it comes to fine-tuning Anthropic's Claude Haiku models, the first thing you have to do is look at your data sets. And there are two data sets that are involved in training Haiku, and that's your training data set and your validation data set. There are some specific parameters that you have to follow in order to make your training successful. And the first one is the file format. The file format is JSON-L or JSON lines. And what that means is that each individual entry that you have will be on a single line in JSON format, followed by the next one, and so on. So each line represents an individual training item for your model. There's some file size limitations as well. For training data, less than or equal to 10 gig, and for validation, less than 1 gig. Line count, there are a maximum of 10,000 lines that you can have, both combined between training and validation. So, for example, you can have up to 10,000 lines of training and 1,000 lines of validation. But at the same time, if you were to combine them, you would have to lower or increase one or the other so that you don't exceed 10,000 lines. So maybe 9,000 lines of training data and 1,000 lines of validation data will give you that total that you have of 10,000 lines. As far as the data structure, we follow the messages format, and we have a link to that format in the QR code to the right. But the main thing is that you have this user and assistant alternation between the model and the user. So rather than having it as a single line where all the data is on a single line, instead you still have that single line, but the user content is separated from the assistant content, and they have those flags of user and assistant. There's a token limit per entry of 32,000 tokens, which is really difficult to estimate off the top of your head, I'm sure. So that ends up being roughly between 125 and 128,000 characters. So if you can use that to help filter it out, that also helps. And then we have some reserved words that you should not use in your training data, and that is /human and /assisted. Those are reserved. In order to make your training data clean and valid, you want to use our data validator tool, which actually checks all these parameters for you and flags the ones that don't meet these parameters. That way you can make sure that you have a clean data before going into the actual fine-tuning process. So some best practices when it comes to data set creation: focus on quality over quantity. It's much better for your outcomes to have a few high quality examples, maybe 100 or 500 high quality examples versus 5,000 of mixed quality. The better the quality, the better your results. Start with a small high quality data set and then iterate based on your results. So rather than trying to train the model in your first run on all your data, start with something smaller, a smaller subset, make sure that it's really high quality, and then go ahead and see where you land from a training data results perspective, and then iterate over time. When you're using larger Anthropic models, you can use larger Anthropic models such as Claude 3 Opus or Claude 3.5 Sonnet to help refine and improve your data. You can actually feed your data into Claude 3 Opus or Claude 3.5 and ask the language model itself if there's some improvements that can be made in your training data. And they actually are very good at helping you find those discrepancies where they might get caught during training and impact your results. Don't forget about prompt engineering. Prompt engineering should have been done before you started the fine-tuning process, but it should also be done after, because you've slightly changed the way the model behaves. Your prompts may also need to be updated to align more with what the fine-tuned model results are giving you. And then lastly, you can use the larger models to actually generate training data for fine-tuning Haiku. And believe it or not, in this demo, we actually did that. And I'll show you a little bit more about that as we go along. It could be really, really effective when using those larger models. And that effort of using larger models to create data for smaller models is called model distillation. And now let's switch to a demo so you can see what that process looks like from inside the AWS console. Our journey to fine-tuning, you might think, starts by immediately clicking in Amazon Bedrock, but it doesn't. You actually start in S3 because that's where our training and validation data sets get uploaded to. So let's take a look at those. In S3, I've created a bucket for model evaluation, and I've created a small folder here in that bucket for demo. When we look at that folder, I also created a subfolder for results. And here we have two different data sets. I made it easy to identify the training data from the validation data set by simply embedding training and validate into their names. But I also embedded a little bit of extra metadata. In this case, 4K means that this particular data set has 4,000 records. And on my validation data set has 1,000 records. It's definitely a good idea to embed into your file structure some level of metadata so that you know what's there. In addition, because you're using S3, you want to make sure that you enable encryption, because your data sets may have private information, and it's always a best practice to do so. And you also want to have versioning enabled, because you may actually make changes in different versions of your files and upload them, sometimes with the same file name, and overlap each other, and you have the ability to roll back and get the previous version. So it's also a good idea to have versioning enabled when it comes to S3. So now that we have our training data and our validation data uploaded to S3, and we have a results folder, now we can go to Bedrock and see how we can fine-tune our model. So we'll go to our search bar and we'll type in Bedrock. And on the left-hand side, we're going to go ahead and click to expand our menu. And just a little bit down under foundation models, you will find custom models. You'll click custom models, and this will bring up our model customization or fine-tuning screen. There are two tabs that are important. The first one is the models tab, which is there in front by default. And then we have the jobs tab. So whether you start on your model or the jobs tab, you're going to go ahead and choose the customized model and create a fine-tuning job. In our case, we're going to click select model. We'll choose Anthropic Claude 3 Haiku, because that's going to be our base model. And then we come up with a model name. So for your model name, just like with the file names in S3, I recommend finding some way to embed metadata into your file name. So in my case, just like we saw earlier, I have Haiku as my base model. You see the 4KT, that's 4K training. 1KV, that's 1K validation. We have some other parameters that we'll look at in just a few moments. For the job configuration, I generally just copy the same name as the model and just add a J at the end so that I can notice that both the model that I created as well as the job kind of align with that same metadata. And here's where our S3 bucket becomes relevant. Here's where we're going to choose our input data, which is our training data. So we'll browse, go to our training data. We'll select the radio button for the training data. and choose that. And then you'll see that we have this validation data set and that it's optional. We'll talk a little bit more about that in a moment, but let's get our validation data set loaded in. Going back to that same folder that we have, and we're going to choose the validate data set. Now, here's where the magic really happens when it comes to fine tuning, and that's where hyperparameters come into play. And you can think of them as the knobs and dials that you can adjust to optimize your model's learning process. When it comes to fine tuning Haiku specifically, there are two key parameters that have the most impact from our testing, and that is the batch size and the learning rate. Our experiments have shown that these factors can significantly impact model performance, with improvements ranging from 2% to 10% across different tasks. So here's some guidelines to kind of get you started. First one is your epoch count. And the epoch count is the total number of iterations of all the training data that you have that are going to be presented to your model in a single cycle. You should aim for 2 to 5, and our default is 2. But today we're going to do something a little bit different. We're going to set it to the maximum of 10. We leave some good defaults there for you, but because we have a validation data set, we're going to set it to 10, and I'll explain why in just a moment. For our batch size, 32 is a good starting point. Here's some recommendations around batch sizes. So let me talk about what batch sizes are. So a batch size is the number of samples processed before the model parameters internally get updated. And batch sizes can vary based on your data set size. So for example, if you have 1,000 plus examples, you may want to try a batch size between 32 and 64. If you have 500 to 1,000 examples, 32, which is our default, is actually a good starting point. But if you have smaller data sets, say less than 500 examples, you may want to consider something like 4 to 16 for this number. So we already know that our data set has 4,000 training examples, so we're going to go ahead and use the higher number of 64. And now we have the learning rate multiplier. And before we talk about the learning rate multiplier, let's talk about what a learning rate is. The learning rate is how quickly a model adapts to new information during training. You can think of it as the size of the steps the model takes when learning. So a higher learning rate means bigger steps and faster learning, but potentially overshooting your objective. When the learning rate multiplier is low, it means smaller steps, and it's a little bit slower, but you have more precise learning. So now let's talk about the learning rate multiplier. The learning rate multiplier is a way to adjust your learning rate for different parts of the model. So imagine you're painting a house. You might use a big roller for large walls, which is your higher learning rate, but a small brush for more detailed areas, which is your lower learning rate. The learning rate multiplier is like choosing different brush sizes for different parts of the house. For a learning rate multiplier, for a target, the range is between 0 and 2, with the default of 1. Higher learning rates work better on larger data sets. So 1 is a good starting point, but you may discover with larger data sets that you want to go a little bit higher. Now we'll see why we're going to have such a high epoch count. And that is because we're leveraging something called early stopping. One crucial concept to understand when fine-tuning is overfitting. And overfitting occurs when a model learns the training data too well, including its noise and peculiarities, to the point where it performs poorly on new and unseen data. It's like memorizing the answers to a specific test rather than understanding the underlying concepts. And so to combat overfitting, we recommend enabling early stopping, which can only be done if you have a validation data set. The initial threshold that we have for early stopping is totally fine. There's nothing that you need to do there for the most part. But now we have something word early stopping patience. Before we get into patience, let's talk about what early stopping itself is. So early stopping is a technique that monitors the model's performance on the validation set during training. And if performance starts to degrade, it indicates potential overfitting, which we talked about earlier. The training process is then halted, and this keeps you from overtraining, and it helps you achieve a good balance between learning from your data and maintaining its ability to generalize in those situations. Plus, you save on time and training costs as well. So, when we set the early stopping threshold, this is the perfect level to set it at to start with. But remember that fine tuning is an iterative process, and you may discover that changing this number over time is actually a good idea. Then, early stopping patience is setting the number of times we will go through the validation data before we decide that the improvements are going the wrong way. So once we've gone, in this case, with a early stopping patience of 2, we will go through the validation process twice after and see if that validation is getting worse or better. In this case, we will try twice, and if the validation continues to get worse, we will stop training. For larger data sets, you may consider setting this to 1. For smaller data sets, you can set it a little bit higher. And then our final parameter that we need to put in for our training is the output data. Where are we going to save our results? So again, we go back to S3. And as you remember earlier, we created a result folder. So I simply need to select the results here. And this is where the output of the training and the validation shows. So you can look at the CSV file so you can see whether you're doing better or worse. So we'll choose that. The last thing that you want to select is the service access role. Based on what you've selected previously in the S3, you can create and use a new service role, which the service will do this for you. You simply name the role, and behind the scenes, our console as well as the Bedrock service will create the right permission sets and create a role that has the right access to your S3 data. In our case, we've already done that, so we're going to use the existing role. From here, we'll create our fine-tuning job. We'll see that it's underway, and we can monitor the results of our training job in the jobs task. So you can see here that our model is now training, and you can also see some previous training models that are completed. Now that your model is completed and finished training, your job is done. The next step is to purchase provision throughput so you can make use of this model. So in our case, we're going to select the radio button for a completed model that's done fine-tuning. We'll purchase provision throughput. Again, you'll see that same idea that I've had previously, which is to use PT in this case, because I'm doing provision throughput, but keep the metadata as far as the model the same. That way it's easy to align what job, what provision throughput, as well as which model we're using. You're going to go down to commitment and terms. In my case, I'm going to choose no commitment, but you have the choice of 1 month or 6 months, and we give you an estimated price of that choice that you've made. From there, you'll click purchase provision throughput. You'll acknowledge that you have chosen no commitment, and you'll confirm your purchase. From there, your model is being spun up for provision throughput. But as you can see, I have one that's already in service. We're just going to take a look at that one briefly. When you click on provision throughput, you can see that you'll get a model ARN. This is the ARN that you will use for your model IDs in your application. So this now replaces any existing model IDs that you may have been using previously, and this becomes the model ID that you will be using in your applications going forward to make use of your fine-tuned language model. So now we want to see what that looks like, though. So first, we can take a look at the text playground. We can go to the playground and try out our fine-tuned model. So we'll go down to fine-tuned models, which will be there automatically for you. We'll choose the model that we want to try. We're going to go with our provision throughput and hit apply. And now this is the language model that we're using. On the right-hand side, we have the ability to adjust temperatures and so on. Now, why am I bringing you here first? Well, first, I'm going to show you something. I have fine-tuned this model. I'm going to use this user interface as an example. When it answers questions, particularly related to the question I'm going to ask it, I want it to put the answer out in a specific format. And this is what I've trained the language model to do. So the first thing the language model is going to reply with is, let's approach this step by step. First, let's carefully read the question, understand what it's asking. The language model on its own is going to present its own logic as to why it's doing what it's doing. And then at the last step, it will say, after careful consideration, I believe the answer is whatever that is, followed by, this makes the most sense. So let's see if that worked out for us. Now I'm going to actually put the question in here, which is a very straightforward question. You're a helpful AI assistant, and I wanted to provide a step-by-step explanation of its answer. What happens if you turn up the thermostat? And I've given it 5 answer choices. Let's see what our output looks like. And here you can see that Haiku has now adopted the training that I've given it. And you can see that its output is very specifically exactly what I've shown you earlier. Let's approach this step by step, colon. First, let's carefully read the question and understand it's asking. The language model then creates its own steps 2, 3, and 4 based on the question that's being asked. And then the 5th step, after careful consideration, I believe answer X is correct, and the answer that makes the most sense amongst the available choices. And that is an example of using fine tuning, in this case, to adjust the way that the language model handles chain of thought or step-by-step type of questions to get an answer that is accurate. Okay, now that you've seen the results of fine-tuning Haiku, a couple of things I wanted to point out, and that is, one, that because we're using Haiku, the response is lightning quick. One of the major benefits of using something like Haiku is that you can get your responses a little bit faster than you would for other models that are a little bit larger. The larger the model, the slower the response tends to be. Another thing that I mentioned earlier, but I wanted to bring back to your attention, is that the entire data set used to train this Haiku model was created by Sonnet. So the Sonnet 3.5 model created the data set that I used to train Haiku. One of the things that I mentioned earlier is one of the best practices, and this is an example of model distillation, where a larger language model like Claude Sonnet 3.5 has created the actual data set used to change the behavior of Haiku 3. Thank you very much for joining this walkthrough of fine-tuning Anthropic's Claude 3 Haiku. I look forward to seeing what you build when you put this new technology to work in your business.